Hello, this is John from caveofprogramming.com, and this is a tutorial on the factory pattern in Java. I'm here in Eclipse and I've got a main method set up already here. Let's take a look at what a factory pattern actually is and when you use it first. So I'll just put a comment here. Factory pattern, or this is also called factory method. Actually, the factory pattern involves creating a class that has one or more factory methods. And this is basically for use in the situation where you want to create lots of objects, let's say, or you want to create one of several possible objects. So we've got a whole bunch of objects that all implement the same interface or derive from the same parent. So want to create objects implementing some interface or having the same parent. So they're kind of objects at the same level in the class hierarchy, let's say. And it's complicated to create these objects because you have to make some kind of complex choice when you're deciding which of these objects to instantiate. So creating an object is complex, and a good example would be if there are lots of constructor parameters. So you've got some object that takes let's say lots of different parameters to the constructor, and the user of that object is going to be baffled as to what precise parameters to supply. But nevertheless, where it's appropriate to use the factory pattern is if it's possible to, let's say, categorize the objects, or to specify in a simple way what object you actually need. So possible to simplify choice of objects somehow. So this is probably sounding a bit abstract. Let's maybe try to look at a couple of examples. I think what I'll do is I'll show you an example of an implementation of the factory pattern, and before that let's maybe take a look at a real world example so you know what we're kind of working towards. That might be a good idea. We've actually already seen the factory pattern in this course because we've looked at DAO factories, data access object factories. I'll show you another example here from the Java Swing API, and the reason that I thought it was important to include this specifically and separately in this course was because, in fact, this is a very, very important pattern which we haven't tackled explicitly in itself. And also, on interviews and exams, you often get asked about the factory pattern, and you'll often get asked for examples of the factory pattern as well. So it's important to know this stuff if you're going to be a Java developer. So the DAO pattern often will use a DAO factory. So that's a good example of it, and we've seen that already. And in the Java API, it's not actually so easy to find. It's not so easy to find examples of factory pattern, but one that springs to mind is border factory. If you've used Swing, you'll know what this is. Let's see, border factory, need a Y there. Let's have a look at this API doc. What this actually is if you have a Swing application, the components can have borders around them. And the borders you could describe as, for example, being beveled borders with a particular width or colour, or etched borders, line borders, I don't know, raised beveled borders, and so on. So they're all different kinds of border, basically. And border factory has these methods, these factory methods, which you call, and they return something that implements the border interface, or it might be it's actually an interface in this case. It could be an abstract class as well, or even a non-abstract class, but this is an interface. So these factory methods are manufacturing objects that all implement this interface. And the reason as to why this exists is because, well, let's take a look at create bevel border, let's say. This returns, we don't even know what kind of object this is returning. We only know that it implements the border interface. And it may be, we don't know just from looking at this, but it may be that there's only one even border object. But that what these methods are doing is that they're configuring it via a whole load of constructor parameters and then returning it kind of pre-configured in a different way. So that's kind of a classic use of the factory pattern. Or it could be that there are several different border classes. I think there are, I don't know. And this is selecting the right one to use and probably configuring it as well. Let's look at the border interface. So yeah, we can see there's lots of different kinds of borders actually, and those factory methods are choosing the right one and configuring it appropriately. Let's take a look at a simple example now of implementing the factory pattern. So I'll take just a kind of silly example here. Let's imagine that we've got a bunch of different animals that we're modeling in software for some reason. So I'll start by defining an interface here. There's no absolutely fixed single form of the factory pattern. It's just the general idea of having a class that has factory methods that return objects. But there are some commonalities that you tend to see over and over again in implementations of the factory pattern, and that's what we're going to look at here, the kind of most typical case. So I'll create an interface called animal, click finish, and let's give this some specify some methods like public, let's say public void speak, and the idea is this is any kind of animal has to implement this, and it makes some kind of noise. I shouldn't have the implementation there actually because it's an interface. There we go. Let's just stick with one method for the moment, and I'll have a couple of objects that implement that interface. So let's have a I'm trying to decide whether we should have stuff like dog and cat or something less specific. I don't know. Let's have dog here. And let's say that dog, whoops, I don't want a main method in it. Let's say that dog implements animal, and let's add the speak method there, and I'll just put sysout woof, and I'll have a cat as well. So new class cat, don't want the main method, click finish, and let's say cat implements animal, and add the unimplemented method speak, and we'll just have a sysout meow. How do you spell meow? There we go. So we've got a couple of animals here now. These are really simple to construct. They don't have a load of different constructor parameters or anything like that. But let's put a comment in here actually. Imagine that this class requires lots of configuration before use, e.g. via constructor parameters. So for some reason, we're not saying what, but for some reason it's really difficult to construct a cat class, and you have to really know what you're doing and give it loads of parameters or something like that. Then we can simplify this using the factory method. So I've got this animal interface. Let's create a new class here, and I'll call it animal factory, just like border factory in the slightly more realistic border factory example, which you can Google if you want to. So I'll create a class here, and I should really put this in a package, and I haven't, but no matter. And we'll give this, we can make this abstract for one thing actually, public abstract class. This is optional. You could decide whether you want people to be able to instantiate your factory or not. And let's have a method here let's have public animal. So it's going to return something that implements the animal interface. Public animal, create animal, like this. So there's lots of possible ways of doing this. I'll just return null for a moment to get rid of that error. It wants me to return something. In the border factory example, we can see that, let's go back to border factory. It's got lots of different methods, like create bevel border, and sometimes they take parameters, like most of them, and sometimes they don't, like create compound border here. In this case, this version of it, certain of these methods don't even take parameters. So as long as you've got some factory methods, then you're implementing a factory pattern, I suppose. But what often happens, or a fairly typical case, is that you'll have one method in your factory which takes some kind of integer or enumerated argument that specifies what kind of object to instantiate. So let's take an example of that. So I could, for example, I could use an enum, which would really be the best way to do this. But in fact, often you see that the factory pattern uses like a public static final int constant to configure this method. So I'll do that since it's very common to do it. Let's say here public static final int cat equals naught, and public static final int dog equals 1, like that. Then here we can make this take an int, which we can call type, and we can switch on the int. So switch on type, and I'll say case cat return new cat. And in a real kind of example, this new would probably be more complex. Because it'd be doing some kind of complex configuration, or possibly just doing some kind of tricky decision about what object to return. And here it's pretty simple. We say we want a cat and we get a cat. But if in a realistic example, you'd probably be either doing supplying a lot of parameters there at this point, or going through some complex decision process to figure out what the best object to return is. And let's say here return new dog, like that. And the default can be to return null. So now to use this, if I go to my app, I could say here animal equals animal factory dot create. Let's take a look. Did I make that public? Yeah, public animal create animal factory dot create. Oh yeah, something important that I forgot to mention is that this should be static, because we want to use it via the class. You don't usually instantiate factories unless there's some particular reason, like you've got to instantiate different kinds of factories or something, but most often you don't instantiate them. So create animal, and then we can say animal factory dot cat, for example, and then finally here I can now use it like let's use animal dot speak. That should be good. Oh yeah, I forgot. This doesn't return a string, it just outputs some text. Okay, so there we go. And hey presto, let's run this as a Java application. There we go, meow. So that's the basic idea behind the factory pattern. As I say, there are lots of variations on this, but the basic idea is just to have some class with a static method that usually takes some parameter, and you say what kind of thing you want, like an etched border or whatever, and it goes through some decision process and returns you an object of the appropriate type. So you won't necessarily know what kind of object you're getting. That's kind of hidden from you. It's the intelligence is in this method that's deciding what you want based on some minimal amount of information that you specify to it. And the idea is just to simplify the construction of objects where otherwise it will be complicated. And it's common, for example, to make, like here, my animals might implement some abstract class. Let's have that just for fun. Let's go to new class and say abstract animal. Often all your objects will implement some abstract class that will provide some basic functionality, like what do all animals do? Let's say public void eat, and let's just have a sys out in there. Chomp, 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 let's say. And then I could say that dog extends, you get the idea, abstract animal, whoops, except I have to put that first before the implements. So this is a pretty common thing to do, but again, optional and entirely up to you. So let's just check that works, and then I'll leave it there for this tutorial. So we'll go to app and animal dot eat dot, did I call it eat? Animal, abstract animal, where are we? This abstract animal, public void eat, and dog extends abstract animal. So, oh yeah, I can't actually use it via the interface unless I add in public void eat, like that. So yeah, the problem there was that this variable can only access methods that are known to the interface of the type which it is. So now we can say eat. There we go. Yeah, so I'll leave it there for this tutorial, and we're going to look at further patterns. There's still quite a few left to cover in this series. And this course is free, but if you're enjoying the course, please try to link somewhere, if you can, to www.caveofprogramming.com, www.caveofprogramming.com. And if you create a link to it somewhere, even if it's just on Facebook or something, then it gets me a better position in Google, which enables me to sell more of my courses, which means I can still keep on making free stuff. So that would be wonderful. And until, oh yeah, I'll put this code on caveofprogramming.com as well, and this course is also on udemy.com. And until next time, happy coding.